this slide, we're going to be focusing on the causes of multiple sclerosis. But let's talk about what multiple sclerosis actually is. MS is an autoimmune disease, which basically means that the immune system gets confused and starts attacking the body instead of protecting it. In this case, it targets the central nervous system, that is our brain and spinal cord. What's actually happening is that the immune system damages the myelin sheath, which is the protective coating around our nerve cells. You can think of the myelin as the insulation around an electrical wire. When that insulation is damaged, the signals don't travel as smoothly. So that's where the symptoms of MS start to show up. Now, something interesting about MS is that it's not directly caused by an infection. There isn't one specific virus or bacteria that gives you MS. But certain viruses, especially Epstein-Barr virus, may act as a trigger, but that's only if someone is already genetically vulnerable. There are also several risk factors. Not just genetics play a role, but environmental things such as low vitamin D levels and smoking affect it. Viral infections might set off the immune response, and MS tends to be more common in women, usually appearing in early adulthood between the ages of 20 and 40. Overall, MS develops because of a combination of genetics, environment, and immune system triggers, not just one single cause. This slide, we're going to be focusing on the history of MS. And to understand how MS came to be recognized, we have to go back to the 19th century. That's when the disease was first identified as its own distinct condition. Before then, people experienced the symptoms, but doctors didn't yet understand that it was one specific disease. The main figure here is Jean Martin Charcot, a French neurologist who's often called the father of neurology. In 1868, he was the first to clearly describe and name multiple sclerosis. Charcot became interested in MS after observing a patient who had tremors, slurred speech, and unusual eye movements. When the patient later passed away, he performed an autopsy and found hardened scar-like plaques in the brain and spinal cord. Those plaques, or sclerosis, are what led him to call the condition sclerose in plaques, which eventually became multiple sclerosis. It's also worth noting that there were earlier descriptions of MS-like symptoms in the 14th and 15th centuries, but Charcot was the one who officially defined it as a medical condition. His work laid the foundation for everything we know about MS today. So he basically coined it. So for this slide, we're going to focus on how biotechnology can actually be used to treat or even potentially cure MS rather than just manage its symptoms. The main concept here is using CRISPR-Cas9, which is a really precise gene editing tool. And the idea is to retrain the immune system so it stops attacking the myelin, as we identified it in an earlier slide. Here's how the process would work. Researchers would take a sample of a patient's immune cells, specifically T cells, from their blood. Then, using CRISPR, they would edit these genes that are responsible for the immune system, misidentifying the myelin as a threat. Basically, the faulty gene is removed or corrected, and a healthy DNA sequence is inserted that teaches the cell to recognize the myelin as harmless. After that, the corrected T cells are grown and multiplied in a lab, ideally, and once there are enough of them, they're returned back into the patient's bloodstream. If this approach works the way it's designed to, the immune system would stop attacking these nerve cells. That would give the myelin layer a chance to repair itself naturally, which could lead to fewer relapses and improved nerve function over time. And what makes this idea promising is that it doesn't just treat the symptoms, it addresses the root cause. And because it uses the patient's own cells, there's a much lower chance of the body rejecting the treatment. And this is a great example of how biotech is moving us towards more personalized medicine and potentially long-term cures for autoimmune diseases like MS. Obviously, there's also external factors that work against this, but in this ideal scenario, it can work.